Hi folks, today's episode in the microcontroller tutorial series is taking care of the one component still missing in our entire tool chain. We've taken care of the the target boards, we've taken care, at least preliminary, we've taken care of the programmers, of the programmer software, and now it's replacing the binary images we've got from the forum with something we compiled ourselves using compiler. It isn't rocket science, but involves something that apparently quite a few people are kind of scared when they just hear the word. It means basically cross-compiling. We're not compiling our software on the system that we want to run it on. I really doubt that you could figure a proper C compiler on a run-of-the-mill microcontroller like the ones we're using. But we do that on a significantly bigger computer. The Raspberry Pi, again, in my case. It's still good enough for the job. And then run it on a different platform. That's not rocket science, but you basically, it makes it easier if somebody points you into the right direction. Okay, these are the two options you need. And not make you read hundreds of pages of documentation for this. The target we're going to start with today is not the MSP430 like last time, because when it comes to compilers, the Atmel AVR stuff is actually a bit simpler. And the good news about having somebody trying things out first and then doing a video about is I already know what hurts the least. So you can start with the simple stuff and then move on to the more complex things. Today it's, well, I've got the board set up here. I've got the webcam again, so we can see the LEDs do some more blinking. So if there was any other way to see that the microcontroller is doing what it's supposed to. And we're going to start with the Atmel AVR. Like in the previous episodes, up here in the right-hand corner, you see the 3 target boards. And yes, I've cleaned up things a little bit, but at the price of lighting not being as nice for whatever reason. There's the Arduino Uno with an Atmel AVR family 80MB32HP microcontroller. There's the TI Launchpad with an MSP430 G2553. And there's the Microchip Debug Express board with a PICC16F887. The first one I want to take a look at is the Arduino. But even before we do that, we should actually take a look at not only some files I've prepared, which are here, but also on how to compile a traditional hello program. And yes, this is just what the name insinuates. Let's take a look at this. This is just about everybody's first C program from whatever textbook or so. If we want to compile that, we use GCC and we just give it the file name and it works. Only problem is by default pretty much all C compilers in the Unix world produce an output file called a.out. Historic thing really. If we run that, it actually works. Not much of a surprise. But what we normally do when we compile these things is to specify an output file. So that would be traditional hello without the extension. Works, runs, not a big deal here. And we can do the same with both the Arduino and the MSP430. It'll be slightly different with the PIC board because we need to use a different compiler there. But before we do that, let's do things properly. One thing you pretty much always want to do is enable warnings. Minus uppercase W for warnings all. Turn on all warnings. Always a good thing to do. And minus pedantic. And what we might also do is explicitly say what C language version we want to use. So that would be -- standard equals C11 for ISO C11 from 2011. So much about having learned anything about year 2000 and going with 2-digit years. Anyway, we run that. and again it works, and it gets us a file, traditional hello. Good. Okay. That was easy. Now, if we tried the same for, let's see, for blink Arduino.c, it wouldn't work. So let's see, blink Arduino without extension, blink Arduino.c doesn't work. First thing we need to fix is we normally want ELF files here. That's just a matter of convention and what compilers produce. We'll see that the SDCC for PIC actually works a bit differently, but okay. We can keep the standard ISO C11 around. We can stay pedantic. We can enable warnings. Everything is nice. Now, if we run that, it's not going to work. Biggest or first problem is we have to use a different C compiler, which is called avr-gcc. And even that doesn't work. And at this point, it's a good thing to actually read warnings and error messages. It says warning, device type not defined. Remember, we're cross-compiling, so the compiler can't simply assume it's compiling things for the platform it's running on. And we tell GCC using -m MCU equals 80 mega 32.8p. Okay, one warning is gone, but there's another one hanging around. Compile optimization is disabled. Functions from utility won't work as designed. There was something about optimization. And when you compile a normal C program, you frequently do something like -O2 or at least O1 or -O without anything to enable compile optimizations. You can do that here as well, but microcontrollers are frequently not maxed out with regard to CPU performance, but they're always short, pretty much by design, on both flash memory for program code and RAM. So what we want to use is -O lowercase s. And no, that's not for speed, that's for size. We do that. Yeah, no more warnings. And we have a file blink arduino.elf. And we can now use our command line history avr dude. And we've already seen about all these things in the previous episode. We just install our new program in the Arduino, and let me make that larger. So you see, no, that's not the Arduino. There's the Arduino. The Arduino is blinking just once before pausing, like from one of the previous programs we've used. Now if you install this new program, no error messages or anything, it blinks 7 times in a row. So this program should actually be called blink 7, but doesn't matter at this point. If you know why things are the way they are, and have somebody recording a video so you don't have to find these things in hundreds of pages of worth of documentation, it's reasonably straightforward. Just remember, you're cross-compiling. You have to tell the compiler what target architecture to use, and compiler name is different, and frequently with microcontrollers you want to optimize for program size or memory requirements rather than speed. Okay, not a big deal. Next target I want to talk about is the MSP430 on the Launchpad. Works pretty much the same. Compiler again is GCC, so a lot of this stuff actually works just like with the AVR. But there is one problem. It's not a technical one so much, but a legal one. Yes. Why is that? For quite some time there was a GCC version supporting MSP430 taken care of by some volunteers, whatever. But some time ago, Texas Instruments decided, hey, let's get actively involved there, which is a good thing. But They added a couple things to the license, nothing particularly exciting as far as I remember, but enough for the Debian people to say, we're not going to touch that. Now, the Debian crowd especially, they are really, well, how to put that in a neutral way, restrictive on what license things to accept, which can be a huge pain in the ass if you need some sort of drivers for some hardware. But on the other hand, which makes sure that you can actually use your machines and not run into licensing troubles later on for whatever you do with them. So it makes sense, but at this point it actually gets in our way. And you can still get the old volunteer maintained MSP430 GCC compiler as a Debian package or Raspbian package in this case. But if you want to use the up-to-date compiler, you have to build it from source. It's a bit of a pain. It takes a lot of time on the Raspberry Pi. So for now, I decided just to stick with the old compiler. It's going to work. And if it doesn't, I'll figure out how to compile it properly. It's not exactly straightforward. I already found out so much. I'll try to get the compiler, the new compiler to work, build another makefile for you to put on the forum page, and you can actually build your own MSP430 GCC from source, like you have to do for the SDCC anyway if you want to use PIC. But for the time being, we're not going to bother about that. We're just going to use the MSP430 GCC that comes with Raspbian, and guess what? It's just another one of those 30-second things to show that it works just like with the AVR stuff. This is how we compile the AVR stuff. Now, the compile is called MSP430 GCC. Big surprise. The target microcontroller is an MSP430 G2553. Another great surprise. And the output file is called blink launchpad.elf, and we need to blink launchpad.c as input file. Yeah, nobody would have ever thought of this, and it actually compiles. Pah! Now let's install it. MSP debug. There's our command line history, and if you take a look at the, let's rescale that again. So you see the MSP430 launchpad thing here is blinking just once, like we had with the Arduino before. We install our new program, and now it's blinking 7 times in a row, just like the Arduino. Who would have thought of that? The only thing that's left to take care of is PIC, and there are a couple of problems with the compiler for PIC. The compiler is called SDCC, the Small Device C compiler, and it's handled a little bit differently, but what's worse, it's usually compiled if you get it as a binary package without support for PIC. Again, due to licensing issues. We'll see that in a moment. If you want to use it, you have to compile it from source, and in episode 37 I've already provided you with a makefile that takes care of all the stuff, at least on a Raspbian. And well, command line options are a bit different, but other than that, yeah. Other problem there is, however, not all PIC microcontrollers are actually supported by that compiler, and the PIC14 family, which is named PIC16F whatever. Yeah, this is just to make things look more difficult than they actually are. They are said to be, well, very early work in progress. The PIC16 family, which are named PIC18F whatever, yeah, they seem to work significantly better, but still they're said to be work in progress. So you don't want to blindly trust your compiler when it comes to these. If you want to use these with open source compilers, be careful about compiler bugs. If you want to avoid that, go with commercial compilers if that's an option to you. Okay, Nothing much more to say. Let's get this done. Let's make this big right away so we can see the LEDs. We have a program blink debug express.c, and to compile it we have to say SDCC, small device C compiler, and the first option we need is use non-free, which only works if we compile things from source ourselves. Now we have to say -m for machine architecture, but now it says PIC 14, which are basically PIC family microcontrollers where command words in the program space are 14 bits wide. That's why they're called like that. And then we have to specify the exact microcontroller, which is done with -p, and that's an 16F887. And yes, family PIC 16 microcontrollers are named PIC 18, whatever. We have to specify the output. And now there's another difference. We don't specify a file extension here. You'll see in a moment why. So we just go with blink debug express, nothing else. And input file is blink debug express.c. We get a warning. So this is actually something I like about the SDCC. Warnings are enabled by default. That's a good thing. The way GCC works there is, well, just asking for trouble because you don't realize something doesn't quite add up. It has a message about some linker script, whatever, not a problem today. And when we say ls, let's say blink debug express everything, you see there's an intermediate assembler output, there's original C file, there's COD, whatever that is, there's a hex file, which is the name of our binary, which is not actually a binary but a hex file. There's some sort of listing, there's an object file. And that's actually the reason why we didn't specify an extension here, because it creates all sorts of files. And that's pretty much it. So all there's left to do is pk2 command to install the binary in our debug express board. And for that to work, of course, first we have to reconnect the PIC2 again, which turns off whatever the microcontroller has been doing so far, which was blinking just once. Run pk2 command. It actually does something. Operation succeeded. And when we disconnect the program again, we see our LEDs blink 7 times in a row. And that's it. Not exactly rocket science. The biggest problem here is actually usually to find the options you need to get things to work in a huge pile of documentation, or at least on Google or DuckDuckGo or whatever. Good. That's pretty much it. And if we take a look again at our outline thing, yeah, we've taken care of all the individual parts. Everything is working. Okay, we still have to learn how to write source code to actually do things, and we're probably going to play around with our own target boards at some point. But we've got the tool chain up and running, which is what a lot of people actually have a lot of problem with when they get started. This is basically the entry hurdle that's really painful to a lot of people. We're taking care of that. There's one more thing left to do, however. Now, we've got taken care of all the individual parts, but what we are going to do in the next episode is getting these orchestrated. Nice fancy word I've learned. Basically means we're going to write a make file to allow us to just say make install, or whatever, and everything else just works. Because as nice as a command line history is, it's just still not enough if you want to get work done. I know a lot of people are afraid of make files, that's why I'm not doing it here right now, but do a separate episode on it. But I'm pretty sure we can get that done in a reasonably understandable way, even if you haven't yet worked with make files or done what pretty much everybody has done when they started with this sort of stuff. Copy a make file from somebody else and tweak it until it, for some reason, however, it works. That'll be next episode. For today, however, that's it. if you want to discuss, if you have questions, suggestions, whatever, come to the forum at www.stepladder-it.com/bivblog/40. And anyway, enjoy. See you probably in a week or so. Bye.